And we are live. Yes. Welcome to another webinar on your favorite topic, Argo CD, and of course, GitOps. My name is Kostis. I'm going to be your host today, and we are going to talk about a very exciting topic, what not to do with Argo CD. Now some housekeeping. First of all, this is recorded. So if you want to leave before the end and you shouldn't, you can do it, and then we will send you the recording. It is also live, so if you have any questions, ask them. It depends on the streaming platform that you are watching us, and if you think that you have an interesting question, now it's your time to ask it, and maybe at the end, if you have enough questions, you can spend some time on Q&A. But other than that, we are ready to start. So Argo CD Anti-Patterns. First of all, why should you listen to me? My name is Kostis. I'm working as a developer advocate at Octopus Deploy. I was actually part of the CodeFresh team, and CodeFresh was acquired by Octopus Deploy last year. I'm a member of the Argo team, focusing mainly on Argo CD and Argo rollouts. Argo rollouts is my favorite project, but today we're going to talk about Argo CD, and I'm the co-author of the first ever GitOps certification. And if you stay until the end, we will give you something very interesting for the certification. Now, you may have seen several articles or presentations that they talk about best practices and how to adopt Argo CD in your company. And here is company X that got Argo CD, and they made faster deployments, faster velocity, faster everything. Here we are going to do exactly the opposite. We are going to tell you what you should not do with Argo CD. So this is not a best practices talk. It's a, let's say, questionable practices talk. And the way we reach this this presentation is a bit interesting. I think after so many years, we have seen customers, we have seen prospects, we have seen people in KubeCon, and we've started discussions with them. And several times we see people that they start with Argo CD and they are not very certain how to maybe organize their Git repositories, how to create their applications. And usually they try some, let's say, questionable practices that work great in the beginning. So if you have like a small team, maybe not too many applications, one or two clusters, everything works great. But then when you want to scale and you have many applications, many clusters, many developers, you realize that what you selected, the strategy you selected in the beginning wasn't the correct one. So we said, okay, let's catalog this. And I wrote this amazing article that you should check if you're into Argo CD, which is called Top 30 Argo CD Anti-Patterns. This is the link, and there is also a QR code. And you can see that usually most blog posts are about 7 or 8 minutes to read. This is 40 minutes, okay? It's a little big. But I think it's a must read, and essentially you should read it and understand that each one of those cases is actually a real conversation with another person or a customer or a prospect. So it's not like, I sat down and was thinking, oh, what should I write today? Let's write these 30 things and let's think about 30 cases. I didn't have to think anything at all. All these are real cases. So if you read this anti-pattern guide and go to a point that says something and you think, oh, this is great advice, but I don't think somebody would do that, somebody actually did that in real life, okay? So this is my, let's say, gift from me to you. Read this article and get to Argo CD in the most, let's say, correct way possible and avoid all the common mistakes that other people have done before you. So after we wrote this blog post, we say, let's do a webinar. And of course, this is super big. We don't have enough time in a single webinar to cover everything. So what you're watching today is actually the second part in the series. We did the first part 2 weeks ago, and there is a recording out there that you can follow. And there we described points 1 until 10, which are, let's say, the easy points, the things that people find when they try to adopt Argo CD and they are in the beginning on the journey. So that was the previous episode, and we can see we talked about how you need to understand Helm before adopting Argo CD, or customize, how you need to adopt correctly multi-source features, how you should split your Git repositories, how you should enable auto-sync and self-heal in all your environments, including production. So if any of these points are interesting to you and you have questions, please feel free to watch the previous episode. Today, we're in the middle. We're going to talk about points 10 until 20, and this is probably the meat or the article. So we have finished with, the initial adoption. You have installed Argo CD, you have deployed some applications, and now it's time to go to the next level. And we talk about several things, such as how, you deal with developers, how we should use application sets, which is my favorite subject, how you should not use Helm, okay, another very favorite subject of mine. And then after 2 weeks, we will go to the super advanced stuff with finalizers. So if you enjoyed this episode, tune in also after 2 weeks. So that's it for the intro. And let's dive straight in, okay? Abusing target revision. Now, we're talking about Argo CD, and if you're not familiar with target revision, once you create an Argo CD application, you should always create an application CRD, which is what you see on the screen. Yes, it's YAML, I know. So this is the application manifest of Argo CD, and it's super simple. It just says to Argo CD, hey, go to this GitHub repo, take whatever is in there. Maybe it's a Helm chart, maybe it's a customized file, maybe it's a plain manifest. I also have a path there to select and then deploy to the cluster. Okay, very simple. But there is a magic field there, which is called target revision. And this field can accept many choices. Here in this example, I have dev, which is a branch. So you can put there a branch, you can put a Git hash, you can put a version number. If it's also a chart, you can put a chart version. But by default, it says head there. Like if you don't change anything, it is just head, which says go to the Git repository, check it out as it is, go to the most recent commit and look at what is there, is in there. So our recommendation is actually to stay with the default. Okay, so use head in target revision. Don't use a hash. Don't use a version number. Don't use a branch. Don't use anything else. Just take the default. And usually people put there a branch name because they want to model environments. So they have environments like dev, QA, staging, and they keep track of each environment in a branch. So don't do that. We have spoken too much about this topic, but you should not use branches for GitOps environments. If you want to model environments correctly, the way to do it is folders. So here I have an example where I have a single monorepo, and I have 3 folders there, QA, staging, prod. I also have the 3 respective environments, and all my Argo CD applications are exactly the same as far as the target revision is concerned. They just mention head and nothing else, and only the path is changing between them. So when it's time for Argo CD to deploy, it looks at the respective path in order to select the correct environment. Okay, that's great, but why you should do this? Like why this is the best choice and why this is a good case to follow the defaults? As always, and I have to say beforehand that I was a developer before I worked with Argo CD, so I always feel the pain of developers and I advocate for them and I want to talk about them. I see a lot of people that adopt Argo CD and they never think about their developers. Okay, you should talk to the developers while you are adopting Argo CD and ask them what they think. Like, okay, we adopted Argo CD. Has your life changed? Is it better? Is it worse? Is it worse? So if you adopt the default and you just leave target revision as head, life for developers is super easy, okay? Because Argo CD is looking at the latest commit by default. If a developer wants to change something in the staging environment or the QA environment, they just do a commit either on a Helm chart or on a customized file, and as soon as they make the commit, Argo CD notifies this. Argo CD is getting notified and deploys the new application. It works great. If you also want to get all the benefits of auditing, if you follow GitOps, again, you have the Git history. Okay, that's the easiest way to do auditing in GitOps. You look at your Git history. So if a developer wants to know what was running last Thursday environment, they go to the Git history and they look what was running last Thursday. It's as simple as that. Okay, that's great. What is even more greater is when you have incidents. So imagine the case where it's 3 a.m. in the morning, a developer is paged, something is wrong, and they see that the last development had an issue and they need to revert right now, okay? Right now, in the quickest way possible. Again, if you use head in the target revision, which means that Argo CD just follows the latest commit, developers can go with their favorite Git tools and run git revert, git reset, or whatever they want to run, then just push, and instantly Argo CD will see the change. So developers have the full power to automatically discard any bad commits and switch back to a previous version. It does not get any simpler than this. Okay, so life for developers is super easy. Everything is great. Now, let's say that you don't follow my advice and you do the fancy thing where somebody says, oh, I want to lock down my Argo CD instance and I'm going to use Git hashes in target revision. Because somewhere they read that Git hashes are more secure in a way, and this is how you lock down an environments. So this is a problem. The problem with this is that now all deployments just became a two-step process, because first somebody needs to commit the actual change in the manifest. Maybe it's a Helm chart or a custom file. It's not really important. Then get the Git hash from that commit, and then do a second commit to the Argo CD application and decide what is the new hash. So this is always a two-step process because you need the output of the first step to put it as input on the second step. Okay, so you just made things more complex for everybody. You created a two-step process that needs manual, I would say, intervention, where things were just really simple. So first of all, you have confused developers. Developers can no longer deploy on their own. If they make a change anywhere in a Helm chart or in a Git repo, nothing will happen. Okay, the developers have read so many articles that Argo CD is amazing, that it automatically syncs your application. You have to just commit and it deploys. And once they actually have time to try this out, they see that it doesn't work. They make a commit and nothing happens. And of course, nothing happens because they didn't change the target revision. Somebody needs to change the target revision for them. Either you need to instruct them to do it. So in this case, you force them to learn about Argo CD and how the target revision works. And developers don't really care about Argo CD. They want to focus on creating programming features and sending their features in production. That is what they want to do. They don't care about Argo CD. They don't want to learn Argo CD manifest. They don't want to learn how target revision works. Or it's your responsibility. Like either they need to open a ticket and you have to do it, or you have to set up an automated process that updates target revision for you. Now, I know what you are going to say. You are going to say, I have an automated process for updating target revision, but I can almost bet right now that what you have only works in happy path scenarios. Like, yes, it's a normal day and somebody deploys and you have an automated script or, I don't know, GitHub pipeline or GitLab pipeline that does it for you. But I can guarantee that when it's time for developers to do something out of the process, so usually you have an incident, your fancy script will not work. So again, imagine it's 3 a.m. in the morning. Okay, a developer is paged and they want to roll back right away. They just want to go to the previous commit or maybe to the last, I don't know, 3 commits, like they want to discard the last 3 commits. Now you have placed a huge barrier on your developers because they cannot do anything before updating the target revision. So either they need to wake you up, okay, and they need to tell you, hey, here is the new target revision, please change it, or you need to have a super smart automated process that allows developers to go back to any target revision that works. And if you have worked as a developer, as an operator, you know that even sometimes at incidents, you're not even sure what is the correct revision. So maybe, you go one version back and you see that you have another problem. Maybe there was a database change and you also want to go another version back, and so on and so on. So if you use hashes in target revision, you make life miserable for everybody, for you and for your developers. Don't do that. Now, there are several other options that you can use in target revision, and we're not going to cover them today. I just wanted to tell you that target revision is one of the topics that you need to pay attention. You can see a summary here at the table on the screen of what we recommend and we do not recommend. In general, we recommend the default. Just leave the default. It's one of those things in Argo CD where the default works just fine. And if you try to do something smarter, essentially, you shoot yourself on the foot. If you want to know more about target revision, there is a full article that talks just for this anti-pattern. This will actually be a very common theme for today. Every time, I will talk about a topic, but if you want to know more, we already have a guide specifically just for this. So go there and read all the do's and don'ts regarding target revision. So that was target revision. Now, a related topic here is misunderstanding immutability. And this is not a problem with Argo CD specifically. It's a problem with the ecosystem in general. Right? Several times I see people that have adopted Argo CD and I ask why they do something with target revision and they put like a hash or a specific tag, or I ask them how they update their Helm charts, and I realize that they haven't mastered the basics yet. And mastering the basic means understanding how Helm works on its own, how Git works on its own, how container images work on their own before adopting Argo CD. So a good exercise, and you can do this even before adopting Argo CD, is to understand exactly what mutable and immutable is your setup. Because I can tell you right now that if you get your fancy, binary artifact and container registry with default installation options, unless you do something really smart or they fixed in the latest versions, you can override container tags. Like I can create a container tag called my application 1.2, submit it and upload it, and then create the same tag, maybe with a different content, and upload it again, and nobody will complain. So by default, container tags are immutable. Helm charts also are mutable by default. Unless you have prevented this with a configuration setting, I can upload a Helm chart with the same version, or I can change the Helm chart and keep the same version. And remember, Helm charts have actually two versions. They have the version of the chart, and they also have the version of the application, and both of them are mutable, and we are going to talk about Helm. And Git tags, even though they are immutable, again, with default settings, you are overriding them. So spend some time to understand about the ecosystem around Argo CD so that you don't fall into the trap of thinking that you have locked down Argo CD, where in reality you haven't locked anything. I think Helm is a great example. Like if you look at the default way a Helm chart works, okay, you don't have a fancy registry. Essentially, you have flexibility to do anything you want as far as versions is concerned. So if we take the most typical case, a Helm chart actually has three versions. It has the chart version, it has the app version, also another field in the chart, and it also has container images like tags for your applications in your image properties. So here I have an example with a Helm chart that has three images, and I can do anything I want. Like unless I make a decision with my team on how exactly I can update my charts, you can see on the first two boxes, I say, oh, I haven't updated anything in my images. The images are exactly the same. Okay, image A is the same, image B is the same, image C is the same, but I fixed something in the chart. So this is how I bump the chart, and it goes from 1.1 to 1.2. But in the second case, again, I make a decision and say I bumped my images. Okay, they go to the next version, but I keep the chart the same. And I'm not saying one approach is correct or the other. I'm just saying that you should talk with your team and your developers and set some rules. So a very simple scenario would be to say that, hey, whenever anything changes in the chart, no matter the change, you should always bump the Helm chart. Okay, that's a good starting point. So here I have an example where even though these charts have the same version, they are different. Okay, so if you think you have locked down Argo CD by saying pick chart 1.2 from a Git repo, you haven't locked down anything at all, okay, from a binary repository. As a final test, and this is something I could ask in an interview question, you can see that if you go right now, like not right now after the webinar has finished, go to GitHub, create a brand new repository with default settings, okay, because there is a setting in GitHub that you can change it, but with default settings. And you can see that I can create a tag v1.2, with content. Yes, that tag is immutable, like in my local workstation, but I can always change the context, delete the tag, and upload it again with exactly the same name. So I can have a GitHub repo where v1.2 5 minutes ago was something, and 5 minutes later it was something else. So maybe you have, Argo CD, an Argo CD application where in target revision you have said use git tag 1.2, and you think you have locked down Argo CD. You haven't, okay? There is a setting in GitHub where you can prevent this. So check your settings. So my point from all this is that people sometimes talk about how they have, thought about security about Argo CD and how their installation is locked down, and they don't understand that they haven't locked anything at all. And Argo CD is pointed to a specific Git tag or a specific chart version or a specific container tag, which might be different from 3 weeks ago, 1 month ago, or something else. So pay attention to all these settings. And essentially, if you truly want to lock down Argo CD, you need to make the whole ecosystem immutable. Like you need to go to your container registry and enable a setting that says that once a Docker image is published with version 1.2, nothing can overwrite it, okay? You need to go to 1.3 and maybe mark 1.2 as obsolete. You need to set up your GitHub repo and say once a tag is created, you cannot remove it. You need to go to your Helm registry and do the same thing. After you have done everything else, then you might start thinking about Argo CD and how to lock down Argo CD. But until you have mastered all this, you haven't locked anything at all. So understand how all these things work. Okay, enough about the locking down. Let's go to communication with developers. And remember, I said I was a developer myself, so I feel the pain for developers. So once you adopt Argo CD, there is a choice of what exactly you want to give to your developers. And here I see several companies that they go on one end of the spectrum or the other. So on the left, we can say, hey, we completely lock down Argo CD. Either developers cannot, change anything, it's just read only for them, or we will say we will not even give them Argo CD. So maybe we want to give them a developer portal like Backstage or Port or Compass or something else, and Argo CD will stay behind the scenes. That's one approach. Or the other approach where people go is let's give them full access. Like developers, we trust them. They know about Kubernetes. They know about Helm. They know about Customize. They can go into Argo CD and do whatever they want. So here I don't have, a clear recommendation. It depends on your company. I'm just saying that there are several other stages in between. Like you don't have to go all the way to the left and lock down Argo CD for all developers, or go all the down or down to the right and just give them full access. There are places in the middle, okay? And depending on how familiar your developers are with Argo CD, it makes sense to examine what they want to do and how you can help them, okay? Always remember that we are here in order to help our developers. So spend some time to understand the possible choices. And Argo CD is designed for multi-tenant systems. It contains an RBAC system where you can get information from your SSO system, get your developers, split them into teams. Maybe the teams match real world teams, maybe that match other kind of teams, and then set privileges and explain what each team can do inside Argo CD, and also define who is like the subject of this action. So you have the typical, who, how, what, like which developer can do what to which application, okay? So spend some time to read the documentation for RBAC and understand all your options. So here I have an example where in my organization, I'm saying, look, for developers, I allow them to do whatever they want in their application. So for their own application, they can, sync it, delete it, update it, change it. But for applications from other teams, they can only look at them, like they cannot do anything. So here a developer tried to sync, which is normally like a very easy action to do, to sync the application from another team. And you can see on the bottom right, they cannot do it because they are not allowed. Again, this is something I set up, like this was my choice. So spend some time to understand RBAC and understand the options that Argo CD offers as far as developers are concerned. There is a great guide for this that you can go and read for more details. Another related topic is how you give access to developers for preview or temporary environments. So this is the old world, the traditional VM world, where you had a static number of temporary environments and developers had to coordinate and choose which environment they were working on. So today, Mike takes staging 1 and Catherine takes staging 2, and nobody else can touch them. With Kubernetes, we don't want the static way of working anymore. We want a dynamic way. We want each developer to create a pull request and then have an environment created for them on the fly, just for them, okay, fully isolated. This is what we want to do. This is what developers actually want. They want to test their feature in isolation. So this is the pattern, and we can implement this with Argo CD using the pull request generator. If you don't know about the pull request generator, you should go and read it after this webinar, okay? You allow developers to continue working as they work. They have the Git repository with the source code, and they go and create pull requests like they have always been doing, just create pull requests. But behind the scenes, you have Argo CD, and it follows those pull requests, takes a base configuration, let's say usually QA, and then creates on the fly applications for them. While you're sitting, okay, I'm not really doing anything. I set up this once and it just works. So here I have an example where two developers started creating a feature at the same time. One feature was called Fix Queue Size. The other feature was called My Billing Feature. And as soon as they created the pull request on the source code repository, without any knowledge of Argo CD, my Argo CD server created two applications just for them in a fully automated way, okay? No tickets, no files, no anything at all. And the magic about these environments is that they have a full life cycle also automated. So if those developers merge those PRs, or if they close those PRs, those environments get destroyed. Or if they commit again, those environments get updated. So if you have this setup, communication with developers is super easy. And if you ask developers if they like Argo CD, they actually don't even have to interact with Argo CD in the happy path scenario. They create a pull request, it gets deployed. They delete the pull request, it gets destroyed. And if you also use vClusters, check vCluster if you haven't seen this project. You can do many more advanced scenarios, not just deploying applications. If you are interested in using the Polar Generator, there is an article, okay, with all the details on how to do this with Argo CD. Referencing dynamic information. This is one of the most controversial points of Argo CD. Essentially, if you follow truly the GitOps principles, you should know that you should use immutable storage for the system. So in our case, this means Git. And if you also use Git, you should be able to have auditing capabilities for free. You should be able to go back to another commit and see how your cluster was looking. This is how things should work. Unfortunately, several people migrate from Helm to Argo CD, and they see that some of the, let's say, Helm features are not supported. So these include the Helm lookup function, the capabilities object for Helm, which essentially make Helm a bit more dynamic. Like you run the Helm CLI, and while the Helm CLI is running, it's querying the cluster for extra information, which is only available at that point in time. And if you have any familiarity, with how Helm works with Argo CD, you know that Argo CD just runs Helm template. So this capability is not possible in Argo CD. So this is not how you normally do things with Argo CD or config management plugins. And I'm saying this because if you go today to the Argo CD GitHub and you look at all the GitHub issues, there is one that is from 2021, so 4 years almost now. And people ask for Helm lookup support in Argo CD, which is understandable. Like, I know what they are asking this. The problem is that even if we add this feature, essentially we lose the auditing and the GitOps capability where you can reason about your environments, because this lookup only works at a specific point in time, okay, or the capabilities object. If I ask you what was the value of this lookup or the capabilities 5 days ago, you don't really know. It depends in the cluster. So you start have some information which is not in Git. Now, there are several hacks that you can do here, like maybe you want to create your own configuration plugin. And again, you should talk with your developers and understand what is their experience. Because if you go down this road of putting dynamic information in Argo CD, again, you make life difficult for developers. So if you find yourself where a developer asks you, how do I run this application? And your first sentence is that they must install Argo CD locally themselves, you are doing it wrong. Developers should not have to install Argo CD locally in order to test an application, okay? You should just be able to take the state from Customize or from Helm. Specifically for secrets, and this is a subset, I'm really happy to report that in the latest version of Argo CD version 3, the secrets page, the secrets documentation page has been updated, and now the Argo team clearly suggests not using this style of post-processing manifests and injecting secrets manually and doing stuff like that. We don't recommend this anymore, even though that several solutions work like this. Instead, we recommend fetching secrets externally, okay? Not the secrets themselves are not in Git, but you should fetch them externally from another secret platform. There is a guide on how you can do this with Argo CD. So this one has, as an example, HashiCorp Vault, which is very popular, a very popular way for storing your secrets, and also the external secret operator. So if you are wondering, okay, but what about secrets? This is the answer. The secrets themselves are somewhere else, and Argo CD just fetches them, okay? But it doesn't query them on the fly. Not using application sets. Okay, so let's go to application sets. I think this is one of the biggest selling points of Argo, how you use application sets. So if you are not familiar with application sets, you should be. It's a great feature, especially if you work with many applications and many clusters. Application sets are useful when you have many clusters and you want to deploy the same application on all the cluster, or you have a single cluster and you want to deploy many applications, or the most usual scenario, you have many clusters and many applications, which is what you have in a big company, okay? So in this case, application sets help you create all the combinations between clusters and applications for you. So go and read the documentation of application sets. Application sets are not an optional feature. Go and understand how they work. You can see here also the pull request generator that we talked before in the previous anti-pattern, and learn how to combine and extend the generators and how to combine them themselves. Because if you look at it like in a big company, in a big enterprise company, here is the twist. You should not actually have to create applications by yourself. So we talked about the application CRD. Normally, this is not something that you create. Okay, you shouldn't have to create this file manually. An application set should write it for you. So if I have 10 clusters and 10 applications, I don't want to write 100 YAML files, even with templating or AI or whatever you want to use. I want an application set to create all the possible combinations for me. This is what I want to do with application sets. So here I have an example, and if you want to play with it, this is the GitHub URL where I have a QA app set, and I'm saying, go to this Git repo, my many apps demo, and in this example, I'm using customize, and I'm saying, go to this folder, apps, take all the applications that have a QA overlay, because I'm working for QA, and then deploy them. And this is just standard customized. Like if you look at the files on the GitHub repo, it's only customized overlays. There is nothing magic. And I don't really care how many applications I have there. Maybe I have 5, 6, 7. It doesn't really matter. Argo CD will just create the combinations for me. I see a lot of people that are asking questions about how you do templating with application sets. And the answer is that you do it the same way as Helm. So all the Helm templating functions, not the lookup stuff and the capabilities properties, but all the standard lookup functions, all the standard templating functions that you have in Helm are also available in application sets. So anything that you could do with a Helm template you should be able to do it with an application set. You should also not confuse application sets with app of apps. I've seen so many teams and they start so many discussions about whether you should use app of apps or application sets. They are not mutually exclusive, okay? It's not like application set is a replacement for app of apps or it's the next generation of app of apps. No, you should actually use them together, okay? That's the recommendation. You don't need to choose. Learn both. Our recommendation is to have your here, like the lowest level, the Helm charts or the customized files. Then you create several application sets according to your needs and you point to those files. And then finally, you group all these application sets in a single file that follows the app of app structure. That's the recommendation. So you can see I'm using both app of apps and application sets at the same time. So here I have an example. Let's see, it's a video. It has no sound, so don't expect any sound. Where I have a completely empty cluster, okay? It has nothing right now. And I'm going and applying for this demo with kubectl, but normally you could do it with Terraform or Crossplane, a single file that has an app of apps collection, which itself contains application sets. And then after I applied, you can see I got, I think, 12 applications from 0 to 12 right away, okay? So this is how you do bootstrapping with Argo CD. And I can take the same file, go to another empty cluster, also apply it, and see the exact same applications. And I have the guarantee that they use the exact same settings. This is actually the example I showed before. So this is how you use application sets and app of apps together. If you don't know where to start, because I think I see so many people that get confused with application sets, start with a simple scenario. First of all, fix your customized files or your Helm files, and then out of all the generators, go read the documentation for the Git generator that will pick your applications, and for the cluster generator that will choose the clusters. Okay, I pick applications and put them in clusters. That's the simplest scenario possible. And then if you need more advanced stuff, look at the other generators or the merge generator or stuff like this. Again, if you want to know more, there is an article which has all the details about how you use application sets and how to also organize your Git repositories, like how to store those files in Git repositories according to our recommendation, and includes instructions both for applications that developers create and also for infra applications. So if you haven't seen this article, you should read it. I think it's a central article for application sets. Which brings us to the next point, the Helm sandwich. I see a lot of companies that follow this pattern where they like Helm so much that they apply Helm everywhere, like everywhere. So here they have like the Helm chart at the lowest level. These are the manifests for the applications that developers deploy. So these manifests are like, deployments, services, config maps and stuff, and they are in a Helm chart. Makes sense so far, great. But then they create application files manually, and they put those in a Helm chart as well. Okay, so you see Helm is here in two levels, top and bottom, and this is why I call this the Helm sandwich. And you have values there, okay? And this is instantly confusing for everybody, that you have two different layers that follow Helm, and one is for application and one is for actual manifest, okay? This also anti-pattern, if you like follow it, you will fall into several other anti-patterns because you have started, with the wrong approach. You are forced to also follow the wrong approach in so many areas. So it's not just the anti-pattern itself, but it's also how you continue working with Argo CD and what you do there. First of all, developers are going to get confused, okay? They are going to get confused. I will guarantee, I can bet with you right now, that they are going to change the values at the wrong level. Like either they will search, the low level and they're going to change the high level, or the other way around, and then they will ping you and say why things went wrong, and you will have to explain this dual Helm structure. So why you should explain a problem that shouldn't exist in the first place. Don't do that. Don't confuse developers. But you're also going to confuse yourselves. Like if you have a new person in your team that knows what's the recommendation, which is obviously application sets, you are going to confuse them with this dual structure. They will make a mistake. You will make a mistake. Like you will change a value at the wrong level when it's 3 a.m. in the morning and you need to roll back and you miss, the correct level of Helm. You will make a mistake. You make your life difficult. What you should do instead, we explained this in the previous anti-pattern. You should use application sets. It's super simple. There is a single layer for Helm, just the Helm chart for applications, which is how things should be, and application sets on top. Okay, that's the best case scenario, and application sets are exactly designed for this case. I said before that I see a lot of people that they like the Helm template functions. Application sets support the exact same functions. Okay, I actually challenge you here to find like a pattern that you can use in Helm and not use in application set. Please, not about lookups and capabilities. I'm talking about the standard templating. So use application sets and template whatever you want. Like if you wanted to use Helm for something specific, you can use application sets. And if you do this, everything would be super simple. There is like a simple way of understanding, where are your applications? They're in application sets, and what they contain Helm charts. Life is super easy for everybody. And if you get a new person in your team and they already know how application sets work, they are good to go. They can understand your structure in 30 seconds. This is how you make your life easy. Hard coding Helm data in Argo CD applications. This is a related pattern with the previous one. So normally, if you follow my advice, there is just one single Helm layer. You have, your Helm chart, your values, and these are things that maybe developers create. And then on the right, you have your application sets that you change, and developers don't need to know anything about them. So this is how things should be. Everybody is super happy and everybody is super clear on what they change. Now, Argo CD allows you, for convenience, to go inside the Argo CRD and change something with Helm, like override directly the values of Helm. Okay, you can do that like there is a capability, but you shouldn't actually use this capability in a production setup. Don't do that. Don't hard code Helm information in application sets. Okay, this is not how things should be. If you do this, essentially, you confuse again everybody because you have two places now where Helm values are stored. Some Helm values exist in value files, the original place, and then you have another set where you override stuff in application CRDs, and there is not a clear separation anymore. So anybody that needs to work with Helm, instantly they need to ask, oh, where are my values? Where should I go? In the application or the values, okay? And remember again, developers, that something that might seem okay with you is not okay with developers. Again, this anti-pattern, if you follow it all the way down, you go into other anti-patterns. And for me, this actually shows something we discussed in the previous webinar, that you haven't understood how Helm hierarchies work. I see so many people that use this pattern and they want to create something that Helm already does, okay? If you know how Helm works on its own, forget about Argo CD. Helm has the capability of defining common properties and then overriding the properties for other environments. This is standard Helm practice. You don't need Argo CD to do this, okay? So if you think that you need applications or application sets to do this, you do not. Again, you destroy the developer experience. If you have, Helm values in Argo CD applications, developers need to have Argo CD installed locally to run an application, or they need to know about Argo CD in order to understand how an application works. And we said we don't want to make life difficult for developers, and we don't want them to have to learn Argo CD. What you should do instead? Store Helm values in value files, like how Helm works, and then mention those values in Argo CD. This is how things work. Everything is super simple this way, and developers also are super happy because they can just get the Helm chart from any application and test it locally. Now, if you combine this anti-pattern with the previous anti-pattern, things become like a real mess, okay? If you have both the Helm sandwich and you also override. Because if you have this, and now you're going to find where a setting is located, maybe it's on the values here at the bottom, or maybe it's on the manifest, or maybe it's on the Helm chart here, or maybe it's on the application CRD, or maybe it's on the values of the application CRD. There are so many choices. Like you have two levels of Helm, and you have also applications that override Helm properties on their own. So if you want to change the setting, you must know in advance where exactly it's located. And I can tell you right now, this creates mistakes. This is how you create mistakes in 3 a.m. in the morning. You will change a property in Helm values where you think your change will take effect, and in reality, it will not take effect. It will be in a different layer or in a different application file. So don't do this. For more information about Helm and how you do Helm hierarchies on their own, there is a guide that explains this exact scenario, and it shows how this is a native Helm capability. You don't need Argo CD to create overrides for you. You can do it with plain Helm. That's how Helm was designed. Same thing for customize. Okay, I'm not going to repeat myself here. If you're using customize, Argo CD also has a capability where you can hard code customized data in Argo CD manifest. Don't do that because, again, you now have customized information in two places. You have it in overlays and in applications, and this is not how things should work. Instead, you should use customize correctly on its own. Just create overlays, and then your Argo CD application files should just mention these overlays and nothing else. And at the end, again, you have a very clear separation. You have customized files that will work on their own, okay? And any developer can take any application, just the customized files locally and test them. And then there are applications, Argo CD applications that don't say anything about customize. They just mention a customized folder or a customized Git repo, and these files are controlled by you, and developers don't need to know anything about this. So don't hard code customize information in applications. Specifically for customize, there is an article. If you want to know how to use customize with Argo CD the correct way and how to use customize overlays and component, go and read this article, and you will see that I talk about existing capabilities of customize even before bringing Argo CD into the picture. Understand how customize works before you work with Helm. Attempting to version Argo CD applications. Essentially, this is the corollary of all the previous anti-pattern. Like here, I want you to understand that if you look at how an application CRD works, you can see it has some very simple fields there. We already explained it has the name of the application, the repository, the cluster, and that's it. You can see there is no version here. Okay, this is by design. Argo CD applications have no version. I repeat this again, Argo CD applications have no version. Several people are getting confused by this and they try to version applications. Argo CD is super simple as far as applications is concerned. You have applications that are static, they are not versioned in any way, and once you promote stuff, you only change, customize overlays or Helm values between existing static applications. So here I have the same application in three environments. As far as Argo CD is concerned, it is just 3 static applications. If I want to promote from QA to prod, I just change the values of prod to match QA. I'm not actually promoting the Argo CD application. You cannot promote an Argo CD application. You cannot version an Argo CD application. I get so many questions about this, okay? Understand that if you're working with Argo CD, as we said in the anti-pattern about the immutable ecosystem, yes, container tags have version, yes, Helm charts have versions, Argo CD applications and application sets don't have versions, okay? If you find yourself that you need versions, it means that you are doing something wrong, and it comes down to all the previous anti-pattern. Like if you have Helm information, for example, in Argo CD applications, then you have your image there, and you change it all the time. Next, you are looking how you are going to version your application CRD manifest. You cannot version an Argo CD application manifest. It was not designed for this thing, okay? So understand what you version and what you promote. And last one for today, running diffs in your mind. So Argo CD has this amazing capability where if you set it this way, it can actually tell you what is different either from a new commit in Git or from a cluster, and then it will render on its own your customized files or your Helm charts, and then it will tell you what is different. And you can get this nice diff where you see final rendered manifest. So here in this example, it doesn't really matter if I'm using Helm or customize, I will just see the exact change. This is a great feature, but for most teams, it's too late in the process. Like I don't want to know about what will change after I made the commit and I'm almost ready to deploy. I want to know what will change much earlier. And unfortunately, if you are using Helm and customize, this is a bigger problem with Helm. If you just use the diffs that your standard, Git provider is providing, you see a diff on the source information, like you see a diff in the Helm chart and not in the final rendered manifest. So this is super difficult to do in your mind. You need essentially to render a Helm chart in your mind, and I don't think humans like to render Helm charts in their mind. Instead, what you would like to see is to see diffs on final rendered manifest. This is what we want. So you can understand exactly the changes that are about to happen in your Argo CD instance. Now, there are many ways on achieving this pattern. Yes, you can pre-render your manifest, or you can have CI there. My only advice here is, first of all, I have written an article that talks about this problem in general and offers several options, and you can choose whatever option you want. And one of them is to have a second Git repo or the same Git repo and render your manifest, but you can also do other stuff. But something that you shouldn't know, that there is a whole project that solves this exact problem. So this is a project from my friend Doug, which is called Argo Diff Preview, and it does exactly this. It launches a temporary Argo CD server that runs the diff for you. So by the time you reach your real Argo CD server, you have a very close result of what will change, and it gives you actual diffs, like final render diffs, not just your Helm charts or your customized files. So if you haven't seen this project, please check it out. It's amazing, especially for large installations. Okay, and that's it. We have talked about anti-patterns 2020. First of all, if you want to know more, go and read this blog post because it has all information. And also, if you have missed the previous 10, it has them. And also, you can see like a teaser trailer for the next 10. So for me, this blog post is like the central hub today. For each of those anti-patterns, I also have a link to a guide that talks about in detail. If you want to see these anti-patterns in practice and you can test them, we are the makers of the first ever GitOps/Argo CD certification, where you sign up and you create Argo CD instances in your browser. Yes, amazing. There is nothing to install in your computer. You just create a real Kubernetes cluster in your browser. Some labs actually have multi-cluster setups, and some of the examples that we have seen today are part of the certification. Now, this has a cost because we pay for the capacity, like it's a real cluster behind the scenes. But if you use the code anti-pattern, you get 50% off, and you can actually apply to any courses that you want. If this is super difficult for you and you want help with your Argo CD installations, there is also support. As I said, I'm also part of the Argo team, and my own team is fully committed to SS. There is a team in Octopus Deploy that works only on Argo CD. I'm talking about the open source project, okay? Nothing to do with Octopus Deploy the product or CodeFresh the product. And we have seen, several use cases in the wild, and we have seen what people are doing. So if you just getting started with Argo CD and you want some help to understand how things are going, or you have adopted Argo CD and you need some help or validation about your existing setup, you can ask us. And as I said, all the things I have explained today are things that I have seen in real life. Like, it's not like I thought about something and wrote it. We have seen prospects that they started with Argo CD, everything worked great, and then they came to us and they asked for help when they could not scale. So that's it for today. I hope it was useful. You should also be at the CNCF Slack. If you aren't there, you should be. The CNCF Slack has Slack channels for every Argo project. So Argo CD, Argo rollouts, Argo workflows. All the developers, including me and my team, are there. So it's a great way to keep up to date with your community, see the problems that people have, and also ask your own questions, of course. But go and read, okay, the guide first. Okay, go read this first. I'm saying this again. If you want to see what people have done before you and all the mistakes they have done before you, please go read this first, and then ask the question in the Slack channel. I'm actually at the point when I'm really happy because somebody is asking a question, and usually I already have a guide for what they were asking. And that's it for today. We are almost on time. If you enjoy this, after 2 weeks, we will close with part 3, which is, let's say, the more advanced anti-pattern. So we'll see more problems that people have faced with their Argo CD installation. Thank you very much for joining. If you have any more questions, feel free to send me an email.